Networking forms the backbone of modern hacking operations, providing both the attack surface and the infrastructure that enables cybercriminals to conduct their activities with increasing sophistication and anonymity. At its core, hacking relies on a deep understanding of network protocols, architectures, and security weaknesses that can be exploited to gain unauthorized access, intercept communications, or disrupt services. The TCP/IP protocol suite, while revolutionary in enabling global connectivity, contains numerous design flaws and implementation vulnerabilities that hackers have learned to weaponize, from IP spoofing and ARP poisoning to DNS cache poisoning and TCP session hijacking. Modern attackers leverage this knowledge to manipulate network traffic in ways that bypass traditional security controls, often using legitimate network administration tools for malicious purposes. Wireshark, for instance, while designed for network troubleshooting, has become a hacker's best friend for packet sniffing, allowing attackers to capture and analyze unencrypted traffic flowing across a network, potentially revealing passwords, session cookies, and other sensitive information. Similarly, tools like Nmap provide hackers with powerful network reconnaissance capabilities, enabling them to map target networks, identify live hosts, discover open ports, and fingerprint operating systems and services, all critical information for planning targeted attacks. The rise of software-defined networking and cloud infrastructure has introduced new attack vectors that sophisticated hackers exploit, including controller vulnerabilities in SDN architectures and misconfigured cloud security groups that inadvertently expose sensitive resources to the Internet. Command and control infrastructure represents one of the most critical networking components for persistent attackers, allowing them to maintain communication with compromised systems while evading detection. Modern C2 frameworks have evolved far beyond simple IRC channels or HTTP callbacks, now employing sophisticated techniques like domain generation algorithms that create thousands of potential rendezvous points, fast flux DNS that rapidly changes the IP addresses associated with malicious domains, and covert channels hidden within seemingly legitimate protocols like DNS or HTTPS. Hackers increasingly leverage legitimate cloud services and content delivery networks for their C2 infrastructure, blending malicious traffic with normal web requests to avoid triggering security alerts. The emergence of peer-to-peer botnets has further complicated defense efforts, as these decentralized networks eliminate single points of failure and make takedown efforts significantly more challenging. On the dark web, specialized bulletproof hosting providers offer hackers resilient infrastructure designed to withstand law enforcement pressure, often operating in jurisdictions with lax cybercrime enforcement. These providers offer everything from DDoS-protected servers to VPN services with no logging policies, creating a thriving underground ecosystem that supports criminal operations at scale. Network-based attacks have grown increasingly sophisticated, with techniques like SSL stripping allowing attackers to downgrade HTTPS connections to unencrypted HTTP without user awareness. Man-in-the-middle attacks becoming more prevalent through tools like Ettercap and Bettercap, and DNS spoofing enabling redirection of victims to malicious sites while displaying legitimate URLs. Advanced Persistent Threat, or APT, groups have developed network tradecraft that includes living off-the-land techniques using built-in network administration tools. They time their operations to match the target's business hours to blend in with normal traffic. Additionally, they compromise network monitoring systems to blind defenders to their activities. The proliferation of Internet of Things or IoT devices has expanded the attack surface dramatically. Poorly secured cameras, routers, and smart devices are often conscripted into botnets or used as pivot points into more secure networks. Hackers have become adept at exploiting trust relationships between networked systems, whether abusing Active Directory federation trusts in corporate environments or manipulating BGP routing tables to hijack traffic at internet scale. The increasing adoption of IPv6 has introduced new security challenges that attackers are quick to exploit. These include the abuse of extension headers to bypass firewall rules and the exploitation of transition mechanisms that bridge IPv4 and IPv6 networks. Network security defenses have had to evolve rapidly to keep pace with these threats, giving rise to technologies like next-generation firewalls that incorporate deep packet inspection intrusion prevention systems that use behavioral analysis to detect anomalies and network traffic analysis tools that leverage machine learning to identify malicious patterns. However, hackers continuously develop countermeasures, including encryption to hide malicious payloads, traffic fragmentation to evade detection, and timing attacks that spread malicious activity over extended periods to avoid triggering thresholds. The cat-and-mouse game between attackers and defenders has led to the development of deceptive defense strategies like honeypots and network deception technologies that create fake assets to lure and identify attackers. Zero-trust networking models are gaining traction as organizations recognize that traditional perimeter-based defenses are no longer sufficient in an era of cloud computing and remote work, requiring verification for every connection attempt regardless of origin. Network segmentation has become critical for limiting lateral movement, with micro-segmentation strategies creating granular security zones that contain potential breaches. Despite these advances, skilled hackers continue to find ways to circumvent network defenses, whether through supply chain compromises that bypass perimeter security, insider threats that abuse legitimate access, or sophisticated social engineering that tricks users into creating openings in otherwise secure networks. The future of networking for hackers will likely see increased automation of attacks through AI exploitation of 5G network vulnerabilities and novel attacks against emerging technologies like network function virtualization and edge computing, ensuring that network security remains one of the most dynamic and challenging fields in cybersecurity.